Welcome back to CAD Level 2, Assemblies and Design for Manufacturing. In the previous module, we explored the standard content library and placed an M4 screw and an M4 nut along the axis of rotation for our joints. Now, let's address the fact that the interference between our two joints makes it impossible for our joints to move. Realistically. We'll create space between the lobes and make some modifications to our geometry to make our parts more easily manufacturable. Back in our assembly, we'll recall that using the interference detection, we have some issues with clearance. Joint A and B will overlap one another when we move our part anywhere from 180 degrees relative to one another. Rather than addressing this in each individual part studio, out of context from the joint's interactivity, let's edit these joints in context of the assembly. I'm going to right-click on one of my joints and select Edit in Context. When I do that, a context is created where we can see the ghostly outline of the remaining parts. Here, we have been taken back into the Joint A part studio. So what do we need to account for? Well, first, we notice that this edge has created a knife edge, inhibiting the mated joint's ability to revolve around its axle. We can see this more clearly if we use the Section View tool, like we did earlier. Clicking on this front face and dragging our section plane back, we can see that, indeed, our part creates a bit of a knife edge. One way to fix this would be to use a fillet. Let's select a fillet and round out these edges. I'll leave the default radius at 0.2 inches. Now, when we use our Section View tool, we can see that we've created some space for our top joint to move. If I accept my section view rather than canceling it, I can keep this view static. Now that this is done, let's go back to the assembly and edit the top joint in context. Let's create a fillet for these shoulders, since we have a similar issue with this knife edge. Now, going back to the assembly, well, we've now run into a problem. While we've created clearance for the lobes of each joint to pass between one another, there appears to have been a shift in our parts. If we use interference detection, we can see that we do indeed have some interference. In fact, it's interference where we didn't have interference before. So what happened? Admittedly, sometimes this is the name of the game. An error has occurred in rebuilding our revolute mate. For now, I'm going to erase it so I can show you what happened. If I separate our parts so that we can rebuild our revolute mate, I notice that now, when I hover over the internal face of this lobe, my mate connector is no longer in the center of my hole. This is because there is now a snapping mate connector in the center of mass of this face. What we really intend to snap to is the middle of this hole, which is now a separate mate connector. When we added the fillets, the mate connector that we had snapped to previously moved, and so it ruined our revolute mate. Let's quickly rebuild it. I'm going to select the center of our hole, and similarly, the center of our hole in this yellow connector, and now that that's done, my parts appear to be aligned. Now, we can see that there's plenty of clearance between the top and bottom joints. In fact, we only see interference when we go beyond about 45-degree angles. If I move my part just so, and refresh the interference detection, we see that we have no interferences between about 45 and negative 45 degrees. However, there's still something that we need to take account of. From the side, you can see that the shoulders of our joints are flush against one another. While this technically works in modeling, it's unrealistic to expect that this is a manufacturable product. We simply don't have manufacturing equipment that's precise enough to generate this geometry without creating some sort of friction or interference. So, what do we do about it? Let's go back and edit these shoulders. I want to show you a new tool called the Thicken Tool. Sometimes this is juxtaposed with the Offset tool. The Thicken Tool allows us to add material to a part, normal to the part's surface. If we select the tool and begin to click on the part surfaces, we see that we add material normal to the part's surface. Let's reduce this to 1 millimeter and choose Remove rather than Add. While we're going in the right direction, we see that we have a slight issue. It might be a cosmetic issue, but our fillet is causing issues with the Thicken tool. So, let's rewind a little bit. Before we use our Thicken tool, I want to first rewind the clock to a time before we were using the fillet. This bar at the very bottom of our features list, called the Rollback Bar, allows us to roll back time. If I click and drag it above the fillet, my model only renders up to the point of the rollback bar. Now, I can choose Thicken, choose this single surface, adjust the parameters, including the direction, and while we're at it, the other side too. When I send the rollback bar to the end of the features list, now including the fillet tool, the fillet will try to regenerate. In some cases, this will work just fine. However, the fillet appears to be confused, so let's fix it real quick. It appears that the fillet was generating off of edges that are no longer existent. So, we can simply choose these new edges, press Accept, and now the shoulders of our joints have been offset, and the fillets of those joints now account for that offset. When we return to our assembly, we can see that the fillets still leave room for clearance in the rotation of our joints, and now we have clearance between the two joint shoulders. Along these same lines, we still have an issue with the clearance of the inner lobes. Let's use Section View to see. Where the green lobe now clears the yellow lobe, the same cannot be said about the inside of the yellow lobe. Also, there's an issue with the flat faces of the lobes themselves. Let's address this problem on the yellow joint. We know that we need to use the Thicken tool. However, first, we need to reverse our time back before we had this fillet. When we open the Thicken tool, choosing Remove mode and 1 millimeter of clearance, we can choose the inside of this channel along with the inside faces of both of these lobes, replacing the fillet and reconstructing the errors. We're ready to go. One quick note. We see in the fillet tool that although we added fillets to what is called the edge of Thicken 1, the feature that we created by thickening or subtracting from the internal channel, we left behind what used to be the surface that the fillet was created on originally. To be complete in our construction, we should delete our old fillet references, such that our fillets are only being generated on the edges of our thicken feature. Now, when we go into our assembly, we can see that we have plenty of room for clearance in between our joint faces, and we still have room on our shoulders and in the internal channel. But if it's not one thing, it's another. It looks like we've broken our revolute mate once again. So what happened? Well, it appears that mate connector A was referencing a face that no longer exists. This makes sense since we technically thickened or subtracted the inner face of the lobe, and now Onshape considers that new geometry. In order to address this, we still have... Furthermore, to address this, we find ourselves in a bit of a pickle. If we were to create a revolute mate between this face and this face, we would have an issue with the fact that now, since the thickness of this lobe is not the same as the thickness between these two lobes, there would be an uneven amount of space on each side of the green lobe. So, how do we center our green joint in between the lobes of our yellow joint? The answer? Let's create a mate connector in between the lobes of our yellow joint. The mate connector tool allows us to create an arbitrarily placed mate connector anywhere on our part. When we click on it, we notice at the top that the origin type is a drop-down menu able to select between two things, on entity and between entities. On entity is straightforward. We can select a point on our model to create a static mate connector. This is relatively uninteresting now, since you would be able to do this normally in our assembly view regardless. What's interesting is this between entities option. First, we pick an entity, placing the origin of our mate connector over the hole, as we had before. Now, it asks us to choose a between entity. If we select the face opposite to the face of our lobe, our mate connector is in line with the hole, but now directly in between these two lobes. This is the nature of the between entities mate connector. When we accept and move back to the assembly, we see our new mate connector floating in space in between the two lobes of our yellow joint. Let's go back into this broken revolute mate, address the fact that since both of our mate connectors are referenced to one side of our lobes, they are both now considered useless. We need to select the mate connector in the center of the axis that drives through the whole of our joints. The first one, which we just made, is floating here in the middle. And now, if we zoom into our green joint and hover over the cylindrical part of our model, you'll notice that we have 3 mate connector points. The centers of the hole on the outsides of each side of the hole, and the center of the middle of the hole. When we hover just right, we can accept that, and now our joints are connected along the center axis of each of the holes. When we move our part, we can see that we have plenty of clearance both on the shoulders of our part and along the sides. One last thing that I want to show is a slight edit to our hole. and go back to edit the hole. I want to bring your attention to the Style drop-down menu at the top of the Hole menu. There's an option called Counterbore, which allows us to create space for the head of the screw in addition for the actual thread of the screw. When we select this and return back to our assembly, we can now see that the head of our screw can fit inside of the recessed part of our hole. We'll need to redefine the mate that constrains the position of this screw. But how about that hex nut on the other side of the joints? Let's do something similar. If I edit in context, I would like to create a hexagonal indentation in this side of the lobe, such that when the nut sits inside of it, and the screw is threaded through the axle and into the nut is held captive. To do that, I'll start with a sketch and place it on top of the nut's face. Next, I'll use the Use Project Convert tool to project the outside line of one of the faces of the nut. Since this is a reference, I'm going to use the Construction tool to make this line a reference. Now, let's use the Polygon tool to create a hexagonal pattern in the center of this nut. When I place my hexagon, my mouse position dictates how many sides my hexagon has. This is a hex nut, and so we need 6 sides. When I click, a hexagon is created. I can place this point in coincidence with this reference point. In doing so, I've effectively outlined the perimeter of our hex nut. However, we need to account for tolerancing and clearance. When we select the Offset tool, we can click and drag the perimeter of a continuous loop. Dropping that perimeter allows us to edit the distance between the offset and the original sketch entity. 0.5 millimeters should do the trick. Now, to be rigorous about this, let's make sure that the inner edges of our hexagon are construction lines, since this is not the geometry that we'd like to use in order to generate our hexagonal hole. When I accept this sketch, when I choose Extrude, I can select Sketch 2 in its entirety, since the only components that are not construction lines are the components that I want to make my extrusion. When I extrude remove, I now need to know how deep my pocket needs to be. To save time, I'll tell you that the nut is about 1/4 of an inch deep. However, in order to create a pocket, starting from the face of our lobe that is 1/4 of an inch deep, let's choose the Up to Face tool. We'll choose this outside face of our part, and you'll notice that we are extruding, removing, all the way up to that face. However, there is no material, so what gives? Well, this is the second part of this equation. The Offset Distance option allows us to designate a distance beyond the face that we've selected. If I designate 0.1 inches here, our pocket is now 0.1 inches deep from the outer face of our joint. Again, to reiterate, this extrusion is occurring offset from our face. So the extrusion extrudes up to the face and then an additional offset distance of 0.1 inches. If selecting the offset distance breaks your sketch, like this, try hitting the Opposite Direction tool. We can accept our part, go to our assembly, edit the fastened mate that dictates where our nut is located, and we're all set. The only remaining thing to do is to edit the length of our screw. And there we have it, a pair of joints with acceptable tolerance for manufacturing, fastened with an axle created by an M4 bolt and nut. This concludes the modeling phase of our hands-on activity. To finish our activity out, our next module will cover how to create a dimensioned drawing of this part, something that you might take to a manufacturing center in order for this part to be fabricated.